Well, the ZeroPM workshop for prioritization, we are addressing a question that a lot of people are asking. They know that there's a lot of persistent and mobile substances out there, or could be out there, but how do we prioritize them? And we can come up with new ways to discuss it, but what is key that we do here is that we link different stakeholders together to try to discuss what they want to prioritize. For some people, it might be the health concerns. For some people, it might be the difficulty of removing from drinking water. So we want to get different people, not just academics, together so we can come up with a prioritization strategy, hopefully, that everybody can agree with. So in my work package in ZeroPM, which is called substance grouping, we're taking a kind of unique approach because it's been very irregular, maybe how chemicals that would be prioritized in drinking water actually made it on that list. Maybe it was usually somebody detected it as a surprise and then they found out it was toxic, and then that would cause some action about this particular chemical, or sometimes it's indirect. They detected a chemical causing problems in wildlife and then they looked for it in water and they found it there too. So there can be different ways, but in substance grouping, we just don't want to do this kind of haphazard, one substance, let's look at it. We want to start from a big chemical data point of view. So we said, why don't we just start looking at all the chemicals that are out there, and maybe all the chemicals that could be out there, and using data approaches like understanding their structure, understanding their properties, how we could narrow down the chemical universe to at least smaller groups to start to prioritize which to get more data on. So it's a unique approach that I think we're developing in ZeroPM, and I think based on the new tools that we're developing through these big data approaches, we're getting a lot of interesting results and a lot of excitement. We can't, of course, go right away to finding what they should prioritize, but we can narrow down from the chemical universe to the most important substance groups we hope that people should look more into in future. Well, in our work package, we already have a lot of good results that we're proud to show at the workshop. The first is we're presenting the work of our global chemical inventory, which is an open access list of all the chemicals that have been registered in different countries so that people can see what chemicals have been registered in their country. And then later, we've also presented our work on how to assess persistence and mobility using a kind of a big data approach. And that is presented by just giving the probability that a chemical could be persistent or could be mobile. So in future, this will be an open accessible list that will be hosted by ZeroPM, by the NGI, where people can see which chemicals in their country have a probability of being persistent and mobile, in case they want to look at that in more detail. We've also been presenting tools to isolate dead-end transformation products, which we think are important. So what is a dead-end transformation product? Well, some of the chemicals that when they're in the environment, a lot of them will mineralize to things like carbon dioxide or water, and they're no longer new or sometimes called novel entities in the environment, but sometimes they break down to stable dead-end transformation products which can accumulate in the environment. And by definition, these are persistent. Now, what the issue is, though we know these exist, we don't know how many are out there. We don't know their chemical identity. So we've been developing tools to look for these persistent dead-end transformation products, and then on top of that, see if they're mobile, which they often can be. So we made new tools for that, presented by Emma Palm. We have our colleague Emma Szymanski. She's also working with these big data approaches, and she made an inventory of how to look at all the PFAS that has ever been put into a chemical patent, available on PubChem and beyond. So this is called the PFAS PubChem tree. And another colleague from Luxembourg, Pavel Chirser, he's going to be presenting how we are grouping or suggesting to group persistent and mobile structures based on this previous work just presented. So based on the structures, if they have a high probability of being persistent and mobile and are associated with a dead-end transformation product, this for us is an indicator that something might be persistent and mobile. And then I will conclude the day by presenting at least how we can discuss how to prioritize these groups based on the data that we have so far, for instance, based on their difficult to treat in water. And then I will be passing it over to my colleague, Work Package 6 leader, Timo Hammers, who will be showing how we can start from these groups and use a risk-based framework to prioritize these compounds.
ZeroPM, Zero Pollution of Persistent and Mobile Substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under grant agreement number 101036756.